All right. Hello, everybody. This is Mr. Klein, and today we're going to talk about part 4 of Unit 1, which is about the spread of the distribution. Listen, we've talked a lot about distributions. We've seen pictures of distributions now, and I'm going to draw one. And we're getting to a point where we need to ask ourselves, how much do we need to talk about to give like a pretty good story of what the distribution is? Well, one thing we learned is that we need to talk about the shape of the distribution. Is it skewed left, skewed right? Another thing we need to talk about is the center of the distribution. Where is the middle? What is the mean or the median or the mode? It turns out that there's one more piece that we need to talk about, and that is like how spread out the values are in the distribution. Let's talk about why. Imagine that you and I, we both get set up, hooked up to a heart rate monitor. So it's going to measure our heart rate in beats per minute, and it's going to take a number of measurements throughout the day. And let's suppose that yours looks something like this. And that mine looks something like this. And let's talk about our average heart rates. Well, as I look at this distribution and this distribution, I say you and I, our hearts, we work about the same way, right? We have an average that is pretty darn close to about 80 beats per minute. So our centers are approximately equal. But does that mean that the way my heart works and the way your heart works are the same? No, I don't think so. Because when you're thinking about a heart rate, you want to think about consistency. Which one of us has a more consistent heart rate? You or me? Well, I would say that your heart rate measurements are much closer to 80 on average than mine. So we would say that yours is more consistent and that mine is less consistent. And again, this idea of consistency means that on average, your values are closer to the middle, which means that yours are less spread out. We would say that you have a small spread. Whereas mine, look at all these points that are very far away from 80 beats per minute, down to 60, up to 100. We would say that I have a large spread. So you get this idea that we can look at a distribution and we can identify whether it's very spread out and inconsistent, or if it has a very small spread and it is consistent. But we need an actual numerical way of measuring this thing called spread. So let's start with a very poor way of measuring the spread, and that's with something you've heard of before called the range. And of course, you know that the range is just the maximum of a data set minus the minimum. So in the case of your data, I would say that the maximum is 90, the minimum is 70. So your range would be 90 minus 70 equals 20 beats per minute. Whereas mine would be, let's see, I go from 60 to 100. So mine would be 100 minus 60 is 40 beats per minute. Oh, you can't see my 40, hang on. And that does show that I have a larger spread than you do. However, imagine that we took two more readings from you. One when you were really relaxed and one when you were really hyped up. So one here and one here. Now you can see that your range is as large as mine. However, I would still say that my data on average are further away from the middle than yours are, which are clustered here. So range can't tell us the complete story. If we want to know the complete story, we have to look at something called a deviation. Here's what a deviation is. A deviation is equal to a value's distance from the center, or in other words, distance from the mean. So I'll use my data as an example here. Here is one particular measurement where I had a heart rate of 90 beats per minute, and my mean was right here at 80 beats per minute. Therefore, if you look at this distance right here, that distance would represent my deviation. I'm going to use the abbreviation DEV. So that would be 90 minus 80 is equal to positive 10. Likewise, if we picked, say, I don't know, this one right here, that's 60. That is 20 beats below my average. So the deviation for this one would be equal to negative 20. It is by calculating each one of these deviations and then looking at something like their average size that we're going to get a good measure of spread using something called the standard deviation. I'm going to show you how to calculate the standard deviation, or the standard size of the deviation, and to use this as a measure of spread. Let's use a simpler data set with specific numbers. Suppose that we're still sticking with a heart rate, and so this is in beats per minute, and that we took 5 measurements this time, one of 65, 2 of them were 70, one of them was 75, and one of them was 80. So the way the standard deviation works is like this. We use S as the symbol to represent standard deviation, and what we do is this. We take each of the deviations. So we're going to calculate the deviation for all 5 of these values. And then we're going to square them. Squaring makes them all positive. And then we're going to add them up. And the symbol that we use for adding things up in statistics, in fact, in everything mathematical, is sigma. We're then going to divide, and this is kind of weird, but we're going to divide by n minus 1. Now recall that n is our sample size. And basically, you are dividing by n minus 1 because we've done experiments and found that if you divide by n, it will make the size of the deviation a little too small. And then you are going to take the square root. Now I'm going to expand this just a little bit. Oh, by the way, that square root, the reason you're square rooting is that it cancels out the square when you're all said and done. Okay, now if I can make one more little note here, it's this. See where it says deviation squared? You'll see that written this way sometimes. There's the squared. A deviation is technically taking an observation. We call those xi. So when I say xi, I mean this would be x1, x2, x3, x4, x5. Each one of the values is an xi minus the middle of the distribution using the mean. You'll recall that the x with the bar over it represents the mean. So this formula and this formula, they are the exact same formula. Let's put them to use. Okay, it's a 3-step process. Here we go. Step 1 is you need to find the mean of your distribution. So in the case of ours, our mean, x bar, would be equal to 65 plus 70 plus 70 plus 75 plus 80. Divide all of that by 5, and you're going to get 72 beats per minute. 72 is right here. You want to look and make sure that that seems about right. Yeah, I've got 2 values that are above it, 3 that are below. The ones that are below look like they're a little bit closer. That's good. The second thing that you're going to do is you are going to construct a table. And that table is going to look like this. First column, list the xi, which were 65, 70, 70, 75, and 80. In the second column, give each one of the deviations. So in other words, how far away are these numbers from 72, and are they above or below? So 65 is 1, 2, 3, 4, 5, 6, 7 beats per minute below 72. So I'm going to call this -7. 70 is 2 below. 75 is 3 above, and 80 would be 8 above. You'll notice that these numbers that I've calculated here correspond to the distances up here. +3, +8, -2, -2, and -7. All right, so I've got my deviations. Now, as we saw in the formula, we need to square them out. So I'm going to square each one of these deviations, which is going to give us 49, 4, 4, 9, and 64. Recall that when you square a negative number, you always get a positive number. Now we want to find the sum of the deviation squared. So we're going to add up 49, 4, 4, 9, and 64. That's going to give us 130, which brings us to step 3, which is to apply the formula. S is equal to square root sum of the deviations squared all over n minus 1. Now, let me show that to you. Now think about what we just did. This number right here, the 130, that is taking the deviations, squaring them, and then adding them all up. So we're going to plug in 130 to our numerator. We're going to divide by the sample size minus 1. There were 5 observations, so this will be 5 minus 1, which means we're really taking 130 and dividing it by 4, which would leave us with the square root of 32.5. At this point, you punch that in the calculator, you get 5.7 beats per minute. I always like to go back and make sure that that seems like a reasonable number. What I mean by that is go and look at the deviations. 5.7 should be smaller than the largest deviation or 2. So it's smaller than 8, it's smaller than 7. We are in good shape.